The next problem is 53rd. So in this question what is asked is a uniform disk of mass m and a radius r is suspended through a wire attached to its center. If the time period of the torsional oscillation is t, what is the torsional constant of the wire? So see, in this problem a uniform disk is suspended. So let us consider a uniform disk here. So just to understand that for the case of ring, the distribution of mass was only over the periphery, but for the disk mass will be inside this region also. So mass will be just like everywhere, but for the case of ring it was like only over the periphery. So this can be understood like this, that this is the difference between disk and the ring. So in this way we have a disk there, but what is asked here is a uniform disk of mass m. So let us consider the mass of this particular disk bm. So mass here is m, the radius is just the r, so radius is r, and the time period given is, so time period given is a t, and it is suspended through a wire attached to its center. So just consider that it is suspended with the help of a thread like this, and this is now twisted. So you can consider it like this is the suspension thread. Here the disc is there, and now it is just twisted. So after giving a twist, the time period observed here is t. So by that time what is asked is the torsional constant of the wire. So for this particular scenario, the time period we evaluate is like 2 pi under root I by the torsional constant. So let us consider that torsional constant bk. So now we have to evaluate the moment of inertia, and that too about the center of mass. So it will be like 2 pi, and moment of inertia about the center of mass will be mr square by 2. So we can write it like 2 upon k. So this value we have evaluated. So the torsional constant will come out in terms of t only. So how we will be doing this problem is t square will be equals to 2 pi, and this value will be mr square. So we have just squared this term. By that time this will also get squared, so it will be 4 pi square and mr square by 2k. So it will come like this. Then we can cancel 2 and pi. So t square divided by 2 pi square will be equals to mr square by k. So k value will be equals to 2 pi square mr square upon t square. So we can get the value of torsional constant like this. So this can be our answer for 53rd question. So it is 2 pi square mr square divided by t square. So this is the answer for 53rd question. So in this way we have evaluated the answer for 53rd.